I'm going to be doing some examples solving quadratic inequalities, and then I'm going to write the answers in interval notation and check them graphically. So the first thing that I need to do to solve this equation, or this inequality, is to get everything on one side and 0 on the other. So I'm going to move the 12x and the minus 9 over to the left, and we end up with 4x squared minus 12x plus 9 is greater than 0. So we want to know, where is this quadratic inequality greater than 0? To be able to solve it, we can either factor or use the quadratic formula. This one's easy enough to factor. It factors into 2x minus 3 times 2x minus 3, and that is greater than 0. So you can see that each of these factors are the same. We just need to solve one of the factors for x, add 3 to both sides, and divide by 2. So x is equal to 3/2. So that means it's going to touch the x-axis at 3/2, 0. So my x-intercept has coordinates 3/2, 0. Now to make a sign chart, I'm going to show where 0 is at, and then I'm going to show where 3/2 is at. I'm going to divide my chart at that 0, and then I'm going to write down my two factors over on the left-hand side, 2x minus 3 and 2x minus 3. So I'm going to pick a number to the left of 3/2. In this case, I'm going to pick 0. If I put 0 in for x, I end up with a negative factor. If I put it in for x on this one, it's a negative. If I multiply them together, they turn out to be positive. If I look for a number to the right of 3/2, so I'm just going to pick 5, and I put 5 in for x, I end up with a positive factor. Same thing with the second one, and when I multiply these two together, I get a positive. So I'm looking for, where is my inequality, or where is my quadratic going to be greater than 0 or positive? So you can see it's going to be positive from the left-hand side up to 3/2, and on the right side from 3/2 to infinity. But what's happening right at 3/2? Well, that's where the function's equal to 0, and we don't want it to be equal to 0. So we're going to put a little open circle here just to make sure that we understand that we're not going to be equal to 0. And to write it in interval notation, it's positive from negative infinity to 3/2, or from 3/2 to infinity. And now we're going to check this graphically. So I have the simplified version of 4x squared minus 12x plus 9 into my y equals. I'm going to make sure that my window is a standard viewing window, so I'm going to go to my zoom and push number 6. Here's my standard viewing window. And then you can see that it graphs, and it comes down right about 1.5. So that does show the same kind of graph that we were thinking about, that it's going to be positive everywhere except right at 3/2. Now if we want to check to see what that number is, we can go to our calculate function, so that's second trace, and we can say, hey, you know what happens at 3/2? So I'm just going to press enter, and it's asking me, okay, what value of x do you want? And I said, well, I want 3/2. And there we are. So when x is 3/2, y is equal to 0, and we have graphed that correctly. And we know now that our graph looks something like this. It's positive everywhere, and that it's above the x-axis, and it's equal to 0 at 3/2, and we don't want to include that in our solution. This example, the quadratic is already by itself on the left-hand side, so we just need to figure out how to factor or use the quadratic formula. And our factors would have to be such that they would add up to 4. And factors of 7 are never going to add up to 4. So this cannot be factored. We need to use the quadratic formula. And remember, the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So now substituting in, x equals negative b, or the opposite of what my b is, which is 4, plus or minus the square root of b squared, negative 4 squared, minus 4 times my coefficient of my x squared, 1, and the constant, which is 7. And that's all over 2 times 1. Simplifying further, 4 plus or minus the square root of 16 minus 28 over 2. So x equals 4 plus or minus the square root of negative 12 over 2, which gives me 4 plus or minus 2i square root of 3. Because of the negative there, I have to have an I in there, all over 2. And then simplifying gives me 2 plus or minus I square root of 3. So what does that tell me? It tells me that there are no real x-intercepts. So no x-intercepts. So then I have to go back and look at my function. And it's a quadratic, and the first coefficient is positive. So that means I have a happy quadratic, which means my parabola is going to be opening up. And I know it's not going to be crossing the x-axis anywhere. So if I were to do a real quick little sketch here, I don't know exactly where it's at. I'm going to have to figure that out. It's somewhere above the x-axis. And I know this because I know it's got to open up, and I know it doesn't cross the x-axis anywhere. So where is this function going to be less than 0 or even equal to 0? Nowhere. It's never going to be less than 0. It's never going to be below the x-axis. So this particular answer is no solution. The problem down here on the bottom involves sketching a region in a plane, the function, and we're supposed to be shading. And you notice right here we have the same function that we had up above. So to be able to graph this function, I need to find the vertex and the y-intercept. So my vertex, I'm going to use my vertex formula. X is equal to negative b over 2a, which gives me a positive 4 over 2 times 1, which ends up being 2. And then my y coordinate of my vertex, I'm going to put 2 in for x into my function. And when I simplify that, I end up with 4 minus 8 plus 7, which is equal to 3. So my vertex is going to have coordinates 2, 3. And then my y-intercept, I'm going to put a 0 in for my x's. And when I put a 0 in for all my x's, y ends up being 7. So my y-intercept is 0, 7. And remember, we're opening up, and we're going to be above the x-axis. So I'm going to go ahead and graph now with my vertex of 2, 3. So 2, 3. And my y-intercept of 0, 7. And remember that we have an invisible vertical line. It's called the axis of symmetry going through our vertex. And everything is symmetrical to that vertical line. So if I have a point at 0, 7, I know I have another point to the right at 4, 7. So then I have a good idea of what my parabola is going to look like. And I want all those values that are going to be greater than, so those y values that are greater than or equal to this quadratic. So what I'm going to do is I'm going to pick a test point. And my test point I usually like to pick is 0, 0. It can be any coordinate pair you want to, as long as it's not on the parabola itself. So I'm going to use 0, 0. So that means I'm going to put 0 in for y and 0 in for x and see if it solves my inequality. If it solves the inequality, then everywhere that in the region where 0, 0 is at, so in this case it would be what I call outside the parabola, if 0, 0 satisfies the inequality, then I'm going to shade everything outside the parabola. If it doesn't satisfy the inequality, then none of the points outside solve the inequality, and that means that my solution must be inside. So putting 0, 0 in for my inequality, I end up with 0 is greater than or equal to 0 squared minus 4 times 0 plus 7. So that means 0 is greater than or equal to 7, which is not true, does not make sense. So that means that none of the points on the outside of my parabola make sense, and my answer has to be inside the parabola. So then if you want to, you can always test and try a point inside the parabola, for instance the point 2, 3. So if we tried the point 2, 3 and we put it 3 in for y and 2 in for x, I think you'll realize that you end up with 3 is greater than or equal to 3. And is that a true statement? Yes, it is. This last one we're going to do is a compound inequality. And what this is saying is y has to be greater than the absolute value of x, and at the same time has to be less than the line x plus 3. So I'm going to do the line first. So remember that we have y is equal to x plus 3. That means that we're going to have a slope of 1 and a y-intercept of 0, 3. And then notice that we have a less than sign. So that means when I go to graph this line, it's going to be a dashed line. So I'm going to go ahead and graph. So I'm going to make 0, 3, and then my slope is up 1, over 1, up 1, over 1. So it's along this line right here. And then the other one I need to graph is y is greater than the absolute value of x. And again, this is going to be a dashed line when I go to graph it. And remember that the absolute value always looks like a v. And in this case, I'm going to be graphing y is equal to the absolute value of x. And it's going to start at 0, 0. And it's going to go in the same slope as the other line I just drew. And it's going to be diagonal and dashed and parallel to the other line. And then I have to also do the negative part, and that's also going to be dashed. So now I've graphed the two different graphs, and I have to solve both of them. So where is y greater than my absolute value? So I'm going to use a test point, and I can't use the test point 0, 0. So I'm going to pick another point. I'm going to pick the point 0, 2 as my test point for both of my inequalities, because that works for both of them. So my test point is 0, 2. So the first inequality, I'm going to put in 0 for x, and I'm going to put 2 in for y. So does the absolute value of 2, is that less than 0? Absolute value of 0. Is 0 less than 2? Yes, it is. So that checks. So that means for my absolute value, I'm talking about all this portion that's inside of the absolute value. So I'll just very lightly shade this if I can. There we go. So everything inside the absolute value. Then I'm going to use the same test point for my graph of my line. So I'm going to put in 2 for y here. And is that less than 0 plus 3? And yes, it is. So that means that for my line, I'm going to be talking about those values that are less than where the line's at. So then that means where are the two graphs intersecting, because that's what and means, and it will be this region in between my line and my positive absolute value.